Today we're going to be reviewing various rules for working with negatives. So you know that when you're adding something together, like 3 apples and 2 apples, that you're going to count them all together and end up with 5 apples. This is not news to you, but what happens if instead of 2 apples, I am adding negative 2 apples? So that means that we've got these 2 symbols right next to each other, addition and subtraction, so we can swap them to get 3 minus 2, which equals 5. Now if it was reversed and it was negative 2 plus 3, we can use our properties of addition and know that we can swap these around. So in any order, the numbers are going to equal the same thing when added together. So we'll swap these around to be 3 plus negative 2, which in turn is 3 minus 2. So if you remember, we're using our commutative property of addition to know that negative 2 plus 3 is going to be the same as 3 plus negative 2. And then we're using what we've learned about our signs when they're right next to each other to know that plus a negative is the same as adding a negative is the same as subtracting a positive. These can be flipped around just the same because they're right next to each other. Now, if we have 2 negative numbers, if it's negative 3 plus negative 2, then we know that we've got 3 apples we owe someone, and there's 2 more apples we owe someone. So in total, we owe someone negative 5 apples. Right? So when you have 2 negative numbers that you're adding, you just add them together and keep the sign the same, just like when you're adding them. When you're adding positive numbers. So if you're adding positive numbers, 3 plus 2 is 5. When you're adding negative numbers, negative 3 plus negative 2 is negative 5. Alright, just remember that the sign stays the same and you add them together when both signs are the same. Now, the last thing to remember is that when you are adding and subtracting a positive and a negative, so negative 3 plus 2. Alright, the sign of the larger number is going to be the one that the sign of your answer is going to be. So do this the same way and be like, okay, well, using my commutative property, that's 2 plus negative 3, and I know from class that I can swap these 2 around and make this 2 minus 3, so it's going to be negative 1. So this is just a check. Be like, well, 3 is the bigger number here, and the sign of 3 is a negative, so I know that my answer should also be a negative, and it is, so I'm on the right track. So that covers adding and subtracting, positive and negative. Well, I guess that was mainly adding. Let's go over subtracting really quickly. So negative 3 minus 2 is the same, as negative 3 plus negative 2, and now it's an addition problem. All right, negative 3 minus negative 2, you remember that our 2 negatives get married and become a positive because marriage is a positive thing. All right, and if we have 2 minus plus negative 3, all right, remember, we switch these around again, and it becomes 2 minus 3. Now let's very briefly go over multiplication and division. So this one is the easiest one of all. Whenever you are multiplying or dividing a positive and a negative, your answer is always going to be negative. Got it? But this is only for multiplication and division. When you're multiplying or dividing 2 negatives, your answer is always going to be positive. And when you're multiplying and dividing 2 positives, your answer is always going to be positive. So for multiplication and division, if the signs are the same, the answer is positive. If the signs are different, your answer is negative. All right, we're going to switch topics slightly and go over one final thing. We're going to review turning fractions into decimals. So if my fraction is 2/5, there are two different ways that I can turn 2/5 into a decimal, because fifths can be multiplied by 2 to get tenths. So I can multiply the numerator and the denominator by 2 to get 4/10. And 4/10 can also be written as 0.4 or 0 and 4/10. The other way that I could do this is I can divide the numerator by the denominator. And remembering I have this invisible decimal point with an infinite number of zeros over here to use. So 5 goes into 20 4 times, that decimal carries up, so 2/5 equals 0.4. The top method is generally going to be easier when you have something that's got over 2 or over 5 or over 10, because you can do that really quickly in your head. However, if you have something like 3/7, you're going to need to divide the numerator by the denominator to get your answer.